All right. So thanks for everybody for coming to the Naisho DeNusumu talk at Notacon 11. So who am I? My name is Adam Crompton. I'm a pen tester, red teamer. Pretty much I love what I do, and I'm very passionate about security. Take the purple pill. It's awesome, and if you don't know what that means, see Dave Kennedy's talk at 4. So I've seen the light. And also, I want to note that I have a wonderful wife that puts up with my personal development. So, yeah. So, all right. So, disclaimer: anything I do or say is on behalf of me and only me. There's no affiliations with anyone but myself. So when I was looking at exfiltration, I kind of wanted to know from a term perspective, what does it actually mean? So I looked up in the dictionary and I saw this. So it says the removal of personnel or units from areas under enemy control by stealth, deception, surprise, or covert means. So I thought that kind of fit the picture. And when I was trying to think about modeling exfiltration, I was kind of thinking wow, this is pretty difficult. There's so many ways and factors involved that, you can exfiltrate data in many ways. So here comes the agenda of what's going to be talked about today. So I'll explain what Naisho actually means as a term. We'll talk about what it does, and then the breakdown of classes that are incorporated in Naisho. We'll run into a demo, and then we'll talk about where the tool would be useful from a red team, purple team, blue team perspective, and then we'll have a final demo and a question and answer. So the meaning of Naisho and DeNusumu is a Japanese term. It's actually, Naisho means secretly, and DeNusumu means stealing. So you put it together, it's secretly stealing. It's a tool for modeling different types of exfiltration methods. It's written in Python and pretty much attempts to avoid detection by blue team tools and tries to make the exfiltrated data look legitimate through traffic and also through covert channels. Staying under the radar is key with any type of exfil. So question to you guys is, if you had data that you needed to exfil, how would you do it? That's one way. Awesome. So if you had data that you needed to exfil, how would you do it? Oh, he said SneakerNet. Yeah. That's rock. SneakerNet is one way. All right. Next. Anyone else? Steganography? Perfect. Yeah, that's one way too. Anybody else? No? Perfect. That's awesome. That works too. Yeah, SE it out of them. Yeah. Perfect. Cool. All right, so when I was thinking about this, I kind of looked at, for staying under the radar, kind of sending packets that would look legitimate and are permitted. So if it's blocked by the firewalls or some type of, so if it's blocked by the firewalls, you don't want to send packets that are being blocked and get notified by the SOC or the blue team. Thread counts need to be realistic because that pretty much sets off alarms. So if you're sending 40 packets at let's say 1 second, you're probably going to get noticed, right? So setting the thread counts to a reasonable amount or something that looks legitimate is pretty needed. And Naisho also provides a level of difficulty and detection too. So I'll switch over to my one Xbox. Oh no. All right. What the fuck? There we go. So there's no. I probably should have showed you the. So this is the file that we'll be using for today. Yeah, for sure. Can you guys see that? All right, cool. So this is pretty much the file that we'll be demoing for today. It's pretty much generated credit card numbers. That's going to be the test file that we're going to be using. All right. So file location, RSA, base64, next, ICMP, and oh, does it? Okay. Displays. You said 1024 by. Okay. Oh, 1024. Sorry about. Yeah. Jeez. You guys see that? Okay, great. All right, so. All right, so if we were to go over to here, you guys can see that. Oh, Jesus. So this is 163. So, so we'll do pretty much. Let's try the TCP socket, which is 172.16.56.163. So in Wireshark, you can see that for this one, that the actual packets that are being sent are malformed and obsolete. But you can actually see that the data that's going over the wire is actually the encoded encrypted text. So this is one way that, this is one level of difficulty that you can use. There's other ways also. So if we use the ICMP packet from the OS system using ping patterns, we can use this too to 172.16.56.163. So we can see that it's an actual echo ping request. But the cool part about this one is it's not being actually sent through the ASCII portion. It's actually being sent through the digits here. So if you look at the 00, then 3974. So let me stop the ICMP traffic stream here. So if you look at this piece here, let's say ending in 17535, and we look over here for the last packet that was sent. 17535. Where's that? Actually, yeah. So this one here, 17535. Yep. Okay. Okay. Cool. It's the last one? Okay. Yeah, so as you can see, it's going through the actual hex values. Thanks, man. It's awesome. And if we were to use actual Scapy, using the ICMP through Scapy, we can see that 116.56.163. You can actually see that it's going through the actual ASCII portion of the text, but it's an actual. It looks like an actual ping request, ICMP request. So, so these are different ways of difficulty that you can use to kind of put it into different segments of the packet. So, all right. So, I think we went over this. So, the next portion is the types of encryption that's actually implemented into Naisho. So we're using asymmetric RSA encryption. Symmetric encryption also, AES and Blowfish is implemented. Encoding There's hex, base 64, base 32, base 16, Caesar cipher, and ROT 13. ROT 13? No? No? Nobody? All right. Exfiltration methods are ICMP, DNS, HTTP, HTTPS, steganography, like somebody said before, proxy gateway, so I can proxy it out, text to a phone, and dump to a file, which is fairly easy. So note, RSA keys on source server is total fail. Don't do that. Like, if you're going to do it on the DeNusumu box, which decrypts the data. So, because forensics will definitely decrypt your data if they take your box. So DeNusumu is the other side of Naisho, where pretty much it decrypts the data. So it's kind of like the yin and the yang. That's why I have it up there. But Naisho's broken out by pretty much 4 main classes. One is encoding. Another one is encryption, exfiltration, and also forensics. So DeNusumu is broken up into 2 main classes, is the encoding class and the encryption class. So you're definitely going to have to know, if you're using AES, the private key that you use to decrypt it, you're okay with, but you're going to have to know how to decode the data. So let's say that you RSA the data, then you base 64 the data, and then you hexed it. On the other side, using DeNusumu to decrypt it, you're going to have to use hex, base 64, RSA, right? Thumbs up? Awesome. I put this in here, PTES standard. I did reference this when I was looking at some of the exfiltration pieces. There's a section in there for post-exploitation, pillaging, and then exfiltration. So if you guys don't know about PTES, definitely read up on it. And then we will do a demo. Knowing that ICMP and HTTP is open to outside, knowing that ICMP and HTTP is open to the outside, the network, how would you get the data out? So, let's keep doing this. So, oh, this looks so bad. You guys even see that? Oh, for sure, man.
Just drop out to the host OS.
Okay.
You got Mac here? What is it?
Yeah, Mac.
All right, drop out to the host OS for me.
Okay.
Go into System. Let's go into Displays.
Okay.
Yeah. You can see that forces it to go dual display.
Okay.
Go into Displays in System. System Preferences.
Yep.
And Displays.
Right there.
And lower that down to, yeah, lower them both down. I'm not sure which one.
Would it be that one?
Yeah, gather windows would. Yeah.
That's perfect?
That's good.
Okay.
How about over the, is that more viewable to everybody out there also, probably?
All right, cool.
Well, actually, we'll switch to your demo to find out, but.
Okay. It's like the Cali, but perfect.
Is that better?
Yeah, that's perfect. Jeez. Thank you so much, Adrian.
Awesome. That is a lot.
All right, so we'll use the CC.sex file, and we'll do, let's say, RSA again, base 64 hex, and we will set up. You guys see this or no? It needs to be bigger. So, sending the data out through, let's say, ICMP or HTTP. I think I already showed you guys ICMP, but so if we only have a one-hop external exfiltration, so let's say it's only a one-hop from my box to that box that's next, we can pretty much use Naisho, but the final demo I'll show you what I mean by using multiple hops. So actually, let's let's do HTTP this time. And the destination box we can set up here. And what is the IP address for this? 170. So 170.24.16.56.170. All right. So port number is 80, and number of data slices. So this option actually cuts the data up in the cookie values to kind of send the data through the cookie portion of the data stream. So is that not listening? It is listening. So 56.160, 170, number 80, number of slices, let's say 300. So in this section of the data, we can see that in the actual cookie value, the data is being sent through the cookie values that are randomized, and it's a post request to that HTTP server over that port. So, and these are the values that are inside of the encrypted data stream here. To make it to obfuscate the data a little bit better, we could probably cut it up into different values or send multiple requests, and I didn't actually do that. So, but you can do that. It's another way. So we can see that the data that we pretty much encrypted, encoded, and sent through HTTP and ICMP actually can get across to the other side. So, all right. So, all right. So, where would this tool actually be useful from a red team perspective? Pretty much penetration tests where you're permitted to exfiltrate flags from the environment. So if you're on an engagement and you're needing to move data after you're in post-exploitation, and you have to move data from one device to the next, which that device that you've already have shell on has access out to the internet somehow, you can use that box to filter all your data out to the internet, right? If you're doing an internal pen test. External, you can do the same, but you can pretty much use, Metasploit download if you're on the internet. So it'll just pull it out through that one data stream. So if it's a HTTP reverse shell, it'll send it out HTTP, same way with any other port. So, another way is pretty much post-exploitation modules for moving data through the network from existing shells. And there's also, I created 2 different executables that you can actually use to route data through exploited boxes. So if I'm actually the pen tester on the Naisho box, and I have 2 different exploited boxes and I have shell on them, I can pretty much drop Naisho binds on those routes and port my data out through the ones that have access out to the internet. So from the Naisho box to the exploited box to the next exploited box and then to the internet. So, and pretty much all Naisho binds can talk to each other. So pretty much, yeah, raw sockets. He asked if I use raw sockets, and I said yes. Perfect. So where would this tool be useful from a purple team perspective? Testing egress filters and tighten them down. So you can use this to kind of baseline to see if, you can actually see the packets going through your SIM or any solutions that you got. And also checking on validation of firewall egress rules. So if you know that ICMP is going from this box that has access out to the internet, maybe you don't want to have ICMP allowed through that box. Maybe you should have some other jump server or jump box to use. This can be used to also validate DLP and also the SIM and add egress filters to the SIM. So knowing what DLP actually catches, you probably should know that, and also putting filters on the actual SIM itself. Also knowing the network, so knowing your actual network flows and kind of seeing if this kind of shows some abnormality in the network flows of your environment. Also validate the SOC response, and I think I put that twice for the blue team also. But so I have a final demo. I'll show how we can use a interpreter shell that's on the box that has access out to the internet, and have a data file that exfiltrates the data out from that box through just sending ICMP and HTTP requests. So, all right. So I need to set this up correctly. So this is pretty much setting up the listener in Metasploit, and I have an RC file that's going to drop the payloads down as it connects, and then we can use that to load up those bind shells. So let's turn this down. So pretty much it's dropping the payloads on the box, the bind ICMP and the bind TCP executable, and we can drop into a shell and see. So the first one is the ICMP one. So we can do Naisho, bind ICMP, exe, and we can do need to know what the box is, the Ubuntu box. Do my bidding. So, so we need to know the IP of this box. Sorry about that. If config 170. So let's bind it to 10.1. Actually, 172.16.56.70. So Naisho bind's running. Now that I did that, got the IP address of this, 163. So where's my Kali box? Okay. So now I can use this to Naisho, now, 1, CC, RSA, base. And we'll do ICMP hex. We can do Scapy if you want. To 172.16.56. I forget this. 163. Hold on 1 second. Oh. 16.56.163. Hold on 1 second. Let me try another one then. 16.6.170. Wait, 163. Why is this not getting it? Alright, maybe that address is not there. So it changed the address, why? So 185, sorry about that. Alright, cool. There we go. So we should see the data coming from the 185 box to the pentest virtual box, which is the Windows box that we popped. So this box that we popped, we're sending data from Naisho to the Windows box to the actual Ubuntu box, and we can do this for any port that's open on the internet. So awesome. Thanks. We can pretty much do that for HTTP also. We set up another bind server on this side. So we use the existing shell that we have, and this is the disgustingness of the socket connection that's set up. Yes. And then we can do another shell to cdc Naisho bind tcp.exe. And we have to give it a port to bind to. So let's say like 80, and then we can actually 8080. We can try 8080 just to be safe. And then we'll send it over to the 170. 116.56.170 box, and then we have to give it a external address that we're going to kick it out from. So let's say kick it out through 80. So while that's running the bind TCP, we can use Naisho again to kick out using this over 116.56.185. Port number 8080. Number of slices of data 3. Actually, I need to set the listener up here. So alright, so should see something pop up here. Yeah, that's not going to give you the full entire packet, so probably need to send it again. 185. Wait for it. Should have sent. Come on, get it working. Uh, 172.16.56. Port number 8080. Should have sent. So it's actually sending through here. It's getting the connection. should pass it on through here. Oh, so there it is. Jeez, what's up with this Ubuntu box, man? It's the same thing I was having when I was demoing this. All right, so you can see that the data that's being sent over the wire is the actual stream of data that was sent in the cookie value from the HTTP box, and it's coming from the 85 box, which is the popped Windows box. So, so what I'm saying is you can have pretty much different boxes in the environment as you roll shells on all these boxes, and if you drop the router Naisho shell, bind shells on these boxes, you can create a tunnel through the network, through your shells, to get them out through the internet. So that's pretty much that demo. Sorry for all the issues. All right, so to recap, Naisho is a tool for monitoring different types of exfiltration methods, and pretty much staying under the radar is key. Any questions? Yep.
On the endpoint side, what are you dumping the data to? Are you pushing it into like a MySQL database, or what would your typical target be for your endpoint?
So, could you repeat the question?
Yeah.
Sorry about that.
Basically, what is your endpoint for the data that you're pushing?
So,
are you pushing it into a database or a raw text file, or what are the typical targets for it?
so if I'm repeating the question, you're saying what is the endpoints of the data that's being sent to? So you can set up a kind of endpoint to route the data through. So let's say that you kind of have an engagement. And you say, if we get the data to this point of the network, we already know that it can be exfilled, right? So if your engagement consists of certain boxes in scope, you can pretty much, as you're going through and popping boxes, you can actually drop these down and get it to that flag server or that destination box and say, hey, we can route it through these traffic, through these boxes based on the pivots that we did, and get the actual traffic to that destination box. Did that answer your question, or not really?
Not really. I'm just trying to figure out a way to generate, a report or something like that, so you can actually show the client or whatnot.
Yeah.
You're actually pushing that valid data rather than just showing them the raw information going across.
Yeah. So
let's say it was a sensitive Excel file.
Yep.
You just dump it out to Excel at the other end, right?
Exactly. So when you decrypt the data on the other end, it would be the actual file that you encrypted. So if you encrypted the Excel file, you would basically send it through the actual Naisho, whatever, and then you get it to the endpoint. Once you get it to the endpoint, there's kind of a manual step of, and I'll show you how DeNusumu works, of kind of taking this file. So this is pretty much the raw data that comes back, right? And let's say /DeNusumu.py. So we hexed it, then we base 64'd it, and then we RSA'd it. And that's the other side of the file. So DeNusumu is the other portion that decrypts the data. So knowing the encoding and also the encryption type that you use to decrypt the data on the other end. So did that answer it, or? Okay. So anyone? Yeah, sure. How big? So the question is, definitely. So the question is, how big is the data packets that are being sent through the ICMP packet stream? They're 32 bits. So it can only hold 32 bits in the data stream of an ICMP packet, so you can't send more. And if you do, then it won't send it, or it'll crash. So 32 bits is pretty much the one. Anyone else have any questions? Sure. Not yet. Oh, sorry. So is this out on GitHub? Not yet. I will be putting it out. I do have a GitHub account. It's encoder on the first slide. So pretty much this on GitHub, and I will be putting it out there. So, yep. Yeah, I use PyInstaller, which is awesome. So I tried to use Py to. Oh, jeez, I know. Sorry. Jeez. So he asks, what type of tool did I use to create the executables for the Naisho binds? Yeah, I use PyInstaller to do that, and use the -- one file on the actual Python script. So, anyone else? Cool. All right. All right. So that's pretty much it. Just want to thank some of my mentors, and also Notacon, so Better Safety Net, McDouglas. So Rollins 007, 614 Family, Skylar, Geek Boy, Mart Landick, and Josiah Wilkinson. So that's pretty much it.